this computer.
I'm
Okay.
actually in the middle of taking the introduction to the packet tracer that they put on Cisco. So I don't know if there's any suggestion that we might also, if we can do it, just to go through that training, or do you think it was it shouldn't interfere with anything that we do?
No, it shouldn't interfere. In fact, it might help you out.
Okay.
It kind of goes over what everything we've already done here, but it might have a little more to it. So.
I know you're about ready to start this, but I think one of the things that I noticed that the Cisco site is a little tricky sometimes where you just have to hit the enter key versus you clicking a radio button elsewhere. I had some difficulty on their site, but other than that, it worked pretty well. The reason I bring it up is because there must be 1,000 videos like what we covered on subnetting alone and how to determine subnets and our worksheets. And I just saw so many methods. I found it refreshing to see how the packet tracer, descriptions and diagrams would pop things up and kind of show it in sequence so you get a feel for the numbers. So
yeah, it kind of brings it all together for you. So this, if you remember, this is what we were working on last time we had class. And so we went through most of the GUI portion of this packet tracer, but we wanted to kind of finish it out here real quick. And then before we start into the other options you can do through the CLI, which is kind of the real way to configure Cisco equipment. So, but just to get you an idea, if you go over to the physical view, you actually have different cities available. And what you can do is this button up here that has a mountain. You click that and you can add a picture, any picture you want. I've got a United States map here. And click apply. And now my city appears someplace wherever I want it to be. We're going to make this over here in Washington. And then you can click a new city if you like. We'll put that one. Oops, that's a new office building. If you make a mistake, you click this little icon here. We'll delete whatever's selected, and it'll ask you if you want to. You sure you want to do that? So, and I did it again. All right, and if you go in, you can get out by using this button here. So we're gonna click delete and delete that. All right, let's try. That's building. That's a city. There we go. All right, so we'll put that over in Chicago. Why not? So now you can go in here, and we have a corporate office made, a wiring closet made, and it looks like everything is included in this one wiring closet. So if you click on that, you can see we've got both our switches and our devices and routers and our servers all in one rack here. So what we want to do is we want to move those. I'm not sure how to do that actually.
Oh, to move it, you click on that that square, that four-way arrow over on the upper right by the 4 boxes, just to the left of the 4 box icon.
Oh, okay.
Yeah.
I see it. Okay.
Yeah. Click on that and then click on the device, and then it will then say, okay, where do you want to move this?
Got
and
it.
then go to city, move to city, and it will give you another city, assuming there's another city available. Yeah.
Okay. I think.
And then you can drag them around by clicking that other
mistake.
The same button again, but just drag it around.
All right. So now I got to go out. My other city.
And for whatever reason, they keep this thing like zoomed up super big. You got to zoom out with the plus and minus magnifying glasses in your drop down or your buttons over on the upper left. just to see it normal.
Oh, I see. I've got all my equipment over here. So this is switch 1. I need to switch 0. I need to move that back.
Go to that office building. Click into that office building right there.
Yeah, hang on.
And then you can go to the office building and you can create a comms closet in there.
I did, but it I may have to
Oh.
move it to the closet. Click on that. Click this. All right. Office building. There we go. Move to wiring closet. Boom. And that city. Move to wiring closet. Okay. So now you get it in here. Routing 1, switch 1. Let's see here. Yep, we got a couple of PCs we have to move.
And if you zoom out a little bit, sometimes it helps you to see if you're dragging around to, let's say you wanted to drag them into different offices or cubes or something to lay it out on top of the office, you know, corporate office map or something.
Yep. What am I missing over here? What is this? All right, so then we've got these in the office. Laptops in the office. You can move around to different rooms if you want, but just for our own purposes, looks like they're all going to. But let's look at the logical. Yep, we still got that. So yeah. And now we got 2 separate cities set up. We got PCs over in the office. Look in the wiring closet. We can see the routers and the switches. So that's all good there. So what else we wanted to do, I wanted to take these laptops and make them wireless. So we're going to look at how to do that here in Packet Tracer. So what first off we're going to do is take out these cables, and then we're going to add a wireless access point.
Do that APTP one if you want. APTP, it's just past the home router.
Yeah,
APPT, sorry, APPT.
I'd like to ask you a quick question, Peter.
Sure.
Let's say that I've got to get up, answer the doorbell. Boy, that dates me. Or walk away. To save this, is there an auto save that's going on, or are you saving it like in a PKT format? Let's say that you've got to go away, come back. How do we keep track of our progress?
Well, that's the whole thing. Is what we want you to do at when you're doing the lab part. You click File, and then Save As,
Okay.
and it will have a packet.
Okay.
Type file, and then you can name it whatever you want and save it.
And not to again feel like I'm getting ahead of your course material, but do you know whether or not we'll be able to find out there free PKT files that might also show other types of configurations that we can play with?
Maybe. I don't know. I haven't actually looked. I'm sure there are out on the internet that you can do. So now we've got access point connected to our switch. So we've got network connectivity wired to the access point. And then we're going to hook up wireless on the laptops. So what you have to do is you have to go to it's got to be physical. Yeah, there it is. Okay. So see here, it's got a network adapter plugged in. We want to change that to a Wi-Fi adapter instead. So what you have to do is you have to turn it off with the button right here. And then you put in, I think it's, yeah, WAC. Now we have to take that out first and then put this one in. And then you turn the laptop back on, and it's now talking to this access point. Let's do the same thing, turn the laptop off, remove that, and put in the WAC. Turn it back on. And now it's talking to that access point. And we've got 192.168.100.2 and not set on this one. So let's go to config. It's DHCP. Ah, there it goes. It's pulling up an address now. And you can actually set up all the different wireless configurations if you like. We're not going to do that today. We've got other fish to fry. But that's pretty much it as far as the rest of the GUI configuration for things, and you can play around with it. There's all kinds of other cabling types that you can play with, or signaling types, that type of thing. What I wanted to do though is get into the actual CLI of the routing devices, and just to give you an idea. So when you start up Packet Tracer, and you put in a router, it will start up the router just like it is a real device. And so you'll get all of the different Cisco systems, iOS, all that type of thing. As it's starting up, all of these different messages will pop up as it starts up. Once you get it started, it will say press return to get started, and then you can then get into the machine from there. But before I get into this, so why do I need to look at the CLI? Why do I need to even look at Cisco? Why Cisco at all? Because you know, there's other manufacturers of networking equipment out there, and you know, why should we even learn Cisco? I guess language, the iOS they have, which stands for Internet Operating System. Well, the reason is that they're kind of industry standard. They invented the router pretty much, and I think they might have invented the switch too. And so the cool thing about Cisco is that their iOS has not changed since the early 90s. You know, when they came up with that's the way it was, and that's the way it has been, and it's not going to change probably. And so since they're so big and so widely distributed across the world, everybody else has emulated, because everybody's learned Cisco iOS. Now all the other manufacturers of networking equipment have emulated Cisco's iOS to be similar in functionality, except for one company called Juniper. Theirs runs a entirely different way of configuring the device, but they've included ways to use Cisco commands to configure it, even though the actual method is completely different. So, and I'll kind of describe a little bit about what the differences are. But that's the reason why you should learn Cisco, is because it's kind of industry standard. And also, if you want to get a certification in Cisco, it's pretty much a guarantee for a job someplace. So they've got the CCNA or CCNP track that you can do through Cisco Networking Academy. I think you can even study for it for free. The tests obviously cost money, but you can get a CCNA, and that will you do that along with some other certifications and maybe a degree from St. Martin's University, and yeah, you definitely get, your job prospects are really good. So anyways, that's the reason why you should learn what we're doing right now. So when you press return to get started, you see my prompt here. If you click on CLI, that's the prompt. If you notice that where it says router, that's got this little caret here, well, not really caret, it's a greater than symbol. That means that you are in a mode called the, like a standard mode. It's restricted. You can only do certain things. Like, for example, I could do a show interface with this, and I can look at the interfaces of the device, but I'm not able to do a show run, which will show me the running configuration. It says invalid input. So I'm not able to, don't have the right privileges to do everything on this device. And this would be helpful if you wanted to set up a user that's limited, if you've got a team of networking guys and you just want to have a guy that can get in and do some show commands to make sure everything's up and running, then you could set him up or her up as that limited user. The way to get into the privilege exec mode is to type the word enable. And if you notice that the prompt now is changed to a hash tag, and that lets you know that you are in privilege exec mode, which is pretty much a like root access to the device. I can do anything I want. So if I want to do a show run now, it shows me the whole configuration for that router. Some other cool command things, like if I was just showing you, I don't have to type in the whole word show. I can just use a SH. You can shorten any command as long as there's no other commands associated with that. So for example, I can't just type in S because there are, yeah, it says an ambiguous command. So, but I can do SH for show. And let's see here. So anyway, so show commands, there are, if I type in a question mark, it will show me all the different commands after that command that are available. So in this case, there's all kinds of different show commands that I can do to show different parts of this router and what's available, like interfaces, IP addressing, the logins, sessions. You can even do SNMP, spanning tree, all kinds of stuff, VLANs, the whole thing. So there's all kinds of different things you can do with this. And this is actually the 1841 router is a fairly old router. In fact, all of the equipment that you see in packet tracers kind of on the old side, just because I think it runs a more lightweight iOS version than some of the newer stuff does. So that's the reason why they do that. But the cool thing is that even though you're learning about older equipment, the iOS is the same since the 90s. And so it's exactly the same nowadays as opposed to back then. So the commands are all the same. The functionality is the same. So.
Peter, can I ask you another question, as I always seem to do? It sounds so basic, but obviously we're looking at a simulation of router 0 there, where we're looking at a command line interface. In the real world, would that just simply be a little 5x7 screen or some plug-in monitor? What would be the actual physical application where you could actually see the keyboard and output for an 1841?
Okay, so there's a couple ways to do this. If you don't have any network access to that device, then you have to use what's called a console cable. And that gets plugged into this little port right here called where it says console. And it's basically an RJ45 cable on one end and a DB9 serial on the other side. So it's a serial cable that you plug into here. Now, nowadays, most laptops or computers don't have a serial port on the outside, so you have to get an adapter. I usually recommend a USB to serial adapter. You can buy them on Amazon. They're like $5. They're pretty cheap. And yeah, that's how you do it. You just plug it in there, and oh, you have to launch software. If you're on Windows, you just do a PuTTY is probably the easiest one to use. I'm not sure if I get it installed on this computer or not.
Yeah,
I do. But PuTTY allows you to do all kinds of things. What you want to do, though, is a serial connection. And COM1 is usually your COM port, but with USB, it might be different. You have to look into your ports and see what port it shows up as. 9600 is the standard speed that Cisco talks on. You can change this to be higher, but for most of the command line stuff, it's pretty 9600 bits per second. That is bits per second. That's not a kilobit or megabit. That's bits per second. It actually is perfectly fine for doing configuration work on the devices.
I didn't want to ask ahead of this, but the idea that we could literally simulate the SSH, or as you say, because you're in your own Windows environment, getting into your console.
Yeah.
That was just something I was thinking out loud, thinking, well, how do we display that? Because otherwise, there's an assumption that we're on one of the other PCs and don't know how we're getting over there. So yeah.
Yeah. Now, what you could do in this type of situation, you could set up a telnet connection or SSH into the routers. I didn't want to go into that depth of configuration on this because it does require setting up a username and password, putting in VTY configurations and things like that. So, and then
that's okay. I just appreciate you
PCs
pulling the curtain back on that
Yeah.
front end of it. So that's a perfect intro to that.
Yeah. All right. So back to the CLI. So there's a couple things with navigating around with the CLI that we want to go over. In addition to the show commands and that type of thing, if you type in something that isn't a complete, it will say incomplete command. So then you can type your up arrow and it will type the same command you had before. And in fact, you can type the up arrow and it will go through your history of the different commands you run. So if you need to repeat something, it's pretty easy just to use the up and down arrows to go through all the different things. Also, if you want to do the question mark is your friend, it shows you all the different commands that are available in each context. So for example, in exec mode, we've got all these different commands just on the hash mark. But if we were going to do a show, then you'd get a whole different list of commands to do under show. In fact, there's a lot more.
Yeah, specific to show, yeah.
Right. Or if you wanted to do, well, we'll get into that in a minute. The other thing you can do is if you're not sure, you can do a show and then we'll try sessions. And then if I'm not sure what the command is, I can do a tab. On a real router, it would come autocomplete for me. Let's try show.
You start typing something and hit tab, it might complete the command for you.
There it goes. Okay, so if you hit the tab key and there's nothing else, it will auto-complete the command for you. Obviously, it won't press enter for you, but and then of course, if I press sessions, it'll say no connections open because we're doing a lab setup here. But the autocomplete is very handy as well. And then on a real device, you can press the tab and it will actually list the different options that start with whatever you've typed in here. So in reality, if you did a show SE, it should show you secure and sessions are both available as SE. But because this is just a simulation, it won't do it. Apparently that's too much processing. So anyways, so the tab key is your friend, the question mark key is your friend. So that's how you kind of navigate around. Oh, and if you need to get back, you know, you get into the couple of different levels in the router or the switch, you press exit and it will get you back to just the regular. You can press EN to get to this mode. Now to actually make a change on the router, you go into configure, and then terminal. Okay, and then I can press exit and get out of that, and I'm back into just the privileged exec mode. You can also, in the shortening of that config terminal is conf T. And so now I'm in config mode, and I can make changes to interface GI 0/0 and oh, that's right, it's an older device, FA 0/0. So fast Ethernet, not gigabit. And that will actually put me on the interface, and I can make different commands on that interface, including shutting it down, setting different speeds, assigning an IP address, IP version 6, that type of thing. So also another thing you can do, so if I type shutdown, that's going to kill my interface. So if you see over here, that killed this interface and it brought this line down. So how to bring that back up? Well, you have to use the no keyword. So no shutdown. Now we're bringing that line back up. It's green over here, orange here. That's because the switch is going through a spanning tree loop to try to figure out if that's got a loop on that line or not. And after 30 seconds, it'll go green here. So, and as you can see here, the output of this, it says the interface fast Ethernet 0/0 is changed its state to up. So.
Okay, I thought of something to ask the two of you, and it might be beyond the scope of this class. I know that I'm familiar with some of the ways that they check, SQL databases for efficiency and load balancing between databases when you're getting information back and forth. But on a router, can the configurations, and excluding any kind of encryption overhead, not that we even covered that, but I see the phrase like MTU and some other things that may check for the efficiency of what's going through that router. Is there configuration commands that might allow you to set preferences for whatever subnets you're connected to? And if not, if we don't want to cover that, I understand it, but I know that in a case where you may want to regulate what's going through that in a wider scope because you've got other higher priority portions of the net that need to have high volume allowed. I don't know if there's a way for you to adjust a router to be familiar with how much bandwidth is being used.
Okay, so you're referring to QoS, which is quality of service, which then
mostly,
prioritizes certain traffic over other traffic. And I'm not sure if we're going to talk about QoS in this class or not.
Okay.
We may talk about it a bit, but it's
well, let me just say this. It would suffice to say that it's the router's job, and most of the switches are not going to have that kind of involvement. Your routers and other gateways and other bridge stuff is going to be the ones where that would be handled, I'm assuming.
Yes.
Okay.
Yeah, the QoS will definitely be done at the router switch. And really, I mean, you can have QoS marking on the actual devices as well, the end devices. So say, for example, a lot of times you want to prioritize phone traffic, voice traffic. So if a Cisco VoIP phone, you can actually QoS mark all of the packets coming out of that phone. So it starts with the phone, goes through the switch, which has a configuration for QoS marking, and through the routers, which then has a QoS marking as well. So
Okay.
yeah, it's all a big system. And like I said, I'm not sure if it's in the scope of this class or not, just because it is big.
Okay, yeah, because obviously what I was thinking of, and I couldn't voice it, is like, could you separate a channel for, or could you separate a particular, you know, packet flow just for that resource? And that's something that I don't know would be covered in just this level. So
yeah, you can definitely do that. Yes, most Cisco equipment allow you to do this. So, all right, so back to what I was trying to do here. Let's see here. We talked about question mark. We talked about the tab key. If you have like I do a show and then a question mark, to get more, you just press the space bar and it will page up for you. So if you have like a show run, it will have a much bigger config, or a much bigger output than what you can fit on the screen. So it will show more here. To get more than that, you press the space bar. You can also do an enter key for that, and it will do line by line rather than the whole thing. But I'm usually impatient and I can read the whole page, so I just do it.
You have returned.
There. So, all right, so now that I've done a show run on here, by the way, that means show running config is what that really means. So that means the running configuration on this router. There are actually two different configurations on Cisco equipment. When you make a change on it, it is instant. As soon as you press the enter key, it is boom, it's live, it's ready to go. So, however, there's, like I said, two different configurations. All you've done then is, when you made it live, that's just a RAM change that you've made. To actually save that, so that if the router gets rebooted for some reason, or that configuration gets corrupted, you have to write it to the flash memory on board, and that's called writing to mem. So before I do that, though, I want to kind of demonstrate what it will happen. So before I do that, I want to go through and highlight this configuration. Yeah, they're right about there. Those are all the different commands that are on this this router at the moment, by the way. And copy. Let's see if I can get to, yeah. Paste that into a document here. So now I've got my own configuration backup of it. So if I were to go into here to the physical and see this little power light, if I click that, I've just turned it off. And if you look at the actual config, it's down. All of the red, it's all red now instead of green. You turn it back on. If you look at the CLI, you can see how it's decompressing its image and going through its boot up process. And it goes through the whole boot up process. That's went really quick, but it gave you all this information about how it's a Cisco product and iOS software. And would you like to enter the initial configuration dialog, yes or no? Now, why do you think we got that? Any ideas? All right, so the reason why we got this is the initial configuration dialog. So when you do a yes on this, it asks you for a basic management setup and an IP address and that type of thing. So you know, what's your host name and that type of stuff. So I don't really want to go through all that right now. So we're going to say no. So I'm going to turn it back off and turn it back on. And we're going to say no next time it comes up. But you'll see that the running configuration on it, go to enable mode, and then do a show run again. It's got a basic configuration, but if you notice, there's no IP address on our fast Ethernets, and they're shut down. And we're still down here, even though the router's on. So we lost all of our configuration. And the reason is because of that configuration. We didn't save last time we were at in class. We didn't save our configuration on here, so it's just running in RAM on the device. Whoa.
What is that config tab there?
The config tab? Yeah.
And
So,
over there where there's a save button where it says NVRAM, if you do save right there, it saves it actually.
yep, you can save it.
Yeah.
I'll also show you how to do it on the CLI. But the really cool thing though is that since we made a backup of it, I can do a Control A, Control C, get into the router and go to config T, and then do a paste, and it just pastes everything in there. At least it should. See what it did here. So yeah, I got an IP address on both of them. They're still shut down because I didn't issue the command to no shut it, but at least I have the IP addresses in there. So what I can do now is I can go back into configuration mode, go interface FA0/0, no shut, and it just went green here. And then go interface FA0/1, no shut, and it just brought that one back up. So now we're back online after messing up and screwing up the whole router and clearing the whole config. All the work that we did to get it all nice and pretty, we flushed it down the toilet. So this is a good way to back up your configs. But then in addition to that, what you can do and what you really should do is get into just the regular exec mode, and the official running config to startup config. So the official Cisco command that they're going to ask on the test is this one, and say yes, or just press enter, and it will then build the configuration. So now if you wanted to make sure that you've got it, you do a show config. Why didn't it do that? Well, that must be a artifact of it being a simulation. But it should have copied. It says building configuration and then OK. You can also, another command to do is write to mem. The same thing. Write to mem is an older command. It's been deprecated, but it's been deprecated ever since I started working with Cisco, and it still works. So anywho, so that's how you will be able to configure as well as save and back up your configurations, and how to use the CLI to navigate around and to make. Is there any questions before I move on to something else?
Just a real quick one, and you just touched on that with the deprecated commands and some of them. This is an 1841, but with the packet tracer, they may have updated or added more devices. Is it possible some of the newer devices would not have the ability to do the deprecated commands, or does most of Cisco stuff still encase most of the stuff that we're doing?
Let's just put it this way. I just put in September, October, a new core switch And for the university here. And it's a Cisco 3850 XS, which is a brand new, the actual switch came out in 2017. The iOS was the latest version, and it still has write and amendment in it. So even though it's deprecated, it still works. So, but if you're asking on the test, this is the command that you have on the test. All right, and so anyways, moving on, unless there's some other questions. Anybody else? Everybody asleep besides Jonathan? All right, well, moving on, let's, right now we've got RIP configured on these routers, and let's not use RIP anymore. Let's use a different routing protocol. Now here on the GUI, you've just got your choice of static and RIP. RIP is, I think it's Routing Internet Protocol is what it stands for, but it's a basic protocol for communicating between routers. They share what networks they're connected to with each other. Now RIP is great if you've got just one or two, well, not one, but 2 or 3 or 4, maybe a max of 10 routers to do. Any more than that, you want to use a different routing protocol. Well, we'll get into it here in a minute. And in fact, next week we're supposed to talk about the different routing protocols. So let me get back into just the exec mode, actually config mode. So you do config T, so we're in config mode, and you do my commands back here. Yeah, type in the word router, do a space, and then a question mark, and this gives you a list of the different protocols that it will talk. So we have BGP, EIGRP, OSPF, or RIP. And so BGP is the language of the internet. This is what all of the big internet routers will talk to each other with. So if you've got something that's internet facing, you're going to need a router that will talk on BGP. A lot of times your ISP will supply this for you. So like here at the university, our ISP actually has a provided router that they've configured. We just put it in our rack and plug it in, and it talks on their network with BGP, and we talk on our network with whatever we want to on our end. EIGRP is another protocol. So the reason why you wouldn't want to do BGP on your own local network is because it's kind of slow to configure. It takes the routers a little bit for them to figure each other out. And when you're on the internet, the routing doesn't change much, so that's fine. It's like, to do a car analogy, BGP is like a big pickup truck, like a semi truck. Whereas EIGRP and OSPF, those are like a Ferrari. They're really small, real light, real fast. So if you do either OSPF or EIGRP, your routers can talk to each other and converge and get established friendships and relationships with each other really quick. And so your network, your whole network, if you've got a pretty complex network, can come together pretty quickly. And then RIP, like I said, it's kind of limited. It's not really designed for a large, complex network. It's more designed for a small to medium size business. So anyway, so today we're going to configure EIGRP. The difference between EIGRP and OSPF is open source. That's what no, that's not what OS means, but it's different. Anyway, so EIGRP, that's actually Cisco only. That's proprietary to Cisco. They've come up with this. And OSPF is basically EIGRP, except it's open source. So the commands are a little different, and the way things are in the protocol are a little different. So you can't configure one router with EIGRP and one with OSPF and they talk to each other. It won't work. You got to have it all or none. So with EIGRP, because it's a Cisco only, that means you have to have only Cisco routers on your network. You can't have any other brands. So if you have other brands, you definitely want to go with OSPF instead. Make sense? Okay. All right, so since we have, okay, oh, one other thing. I keep on remembering things. Let's see if it will work here. So if you're in config mode and I try to type in a show command, it won't work. You got to be in exec mode in order for this to work. Okay. But there is a workaround. If you type in the keyword do show run, then it will actually work in config mode. Just a little tip in case you're playing around and you're tired of typing exit. In fact, I shouldn't have typed exit there. Config T. So now I'm in config mode. Do show router. And let's do a run. See if this pipe command works or not. Include. Oh, it does. Cool. All right. So what I did here is I did a do show run, which is running. It won't do it. But anyway, show run. And then if you do a pipe, that will actually parse out all of this and search. It'll be a search type of thing. And you can do include, which is inc, and then whatever you want to search for. So in this case, I wanted to search for a router, and it came up with router rip. So we want this command gone. So how do we get rid of that command? Anybody remember? How do you turn off something? Like no router. It's gone. So if I do a do show run include router, it's gone now. So it's not talking rip anymore. And so this router does not know how to talk to the other router on our configuration now. It still shows us up because it's physically up, but you can't actually talk between the two at the moment. So what we want to do is we want to do router EIGRP. Oh, and you have to do a autonomous system number, they call it. And so I just do one. If you have a very, very complex and very big network, you might have several different autonomous system numbers. But if you're doing just one local network like we are here, you can do just a single autonomous system area. So router EIGRP1, so that turned on EIGRP now. And now we want to advertise our routes in here. So the commands for that on this one are these two. So network 192.168.100s and the 10.000. See if I can paste. Yep, there it is. So now I'm advertising via EIGRP to these numbers here. These two networks, one going this way and one going that way. Now, since I've made a configuration change on here, I want to issue a write to mem so that it saves the configuration. So I don't get bit by that later. All right, so let's look at the other router we have. EN, big T. Remember, no router RIP, and then router EIGRP. Remember that autonomous system number, we got to have the same number if we're going to be able to talk to these two. If you got different numbers, then it won't work. So router 1, and then we're going to have it talk network 192.168.200.0 and network 10.0.0.0. And as you can see here, instantly, because it's a very fast routing protocol, I've made a neighbor. It's like, hey, I know somebody, 10.15.15. Now a new adjacency, it's called. And you can actually, there's a show command that you can do. Show EIGRP. Is it not in here? Nope. Okay, well, maybe it's route. Anyways, you can show, there's a command that you can do to show the different neighbors that you have. Also, if you did want to see real quick what your IP addresses are on the router, you can do a show IP interface brief. And it will quickly show you what IP addresses and what interfaces they're associated with. And it shows you here, we've got a VLAN 1 on this as well, and it's unassigned because we didn't set it up. It's not necessary for our network configuration. So that's how you turn on EIGRP instead of RIP. Also, other things we can do. So let's instead of router, this gets kind of confusing. So we have router here, and we have router here, and if we had even more, it'd be just router as well. So let's name this something more convenient. So in order to name it, you do host name is the keyword, and then you just type in whatever name you want to call this. So since this one is technically in Chicago, we'll call this Chicago router 1. And now its name shows up here instead of router. Remember, we changed the configuration on here, so we're going to do the copy run start. Yeah. Yeah, that works. Okay. And then, yep, built the configuration. Does that work? I don't know why it doesn't work. Should. Oh, well,
Just put SHO.
we could try that. SHO config. Yeah, it doesn't want to work. On a real Cisco device, you can do a show config, and it will show you what has been saved as opposed to what's running now.
Try
So
show space startup config.
And then if you do a show, yeah, the startup config, you're right. So maybe you should do show startup config. Yeah, maybe. Yeah, there we go.
There you go. Yeah.
So apparently the show config is deprecated. I know the old command, and the new command is the startup config. So. And here you can see our configuration for EIGRP. 192.168.200.0 and 10.0.0.0, and it was auto summarized. In other words, I didn't put in configurations in here to limit it to only the 200 address range. I let it do a classful, which happens to be the 200 address range. Or I didn't do the limit it to only 10.1.1.0. address range. I did the entire 10.0.0.0 range instead. But that's just because we only had 2 routers here and they were talking on a 10 dot. So it was able to do that, no problem. If I want to limit it, I can. You have to use what's called a wildcard mask. And in order to do that, that requires some bitwise learning. It's best to do this in a subnet calculator. So if you go to this website, subnet calculator, it shows up right here when you type in the IP address and subnet mask that you want. You'll have the IP address, net mask, and a wildcard mask as well as a CIDR notation. So I've got a link to this in Moodle. I think it also works with this BitCricket calculator. But I'm not that familiar with this calculator. I haven't used it much. Decimal. Do a /30. Will that work? No. There we go. So will it show me? It doesn't look like it shows the wild card in here. So if you want to know the wildcard mask, I would use the one online rather than the BitCricket. Anyway, so if I did want to do that, go to config T, and then you go to router EIGRP 1, and then you do a no 10.0.0.0, actually no network 10.0.0.0, and now my neighbor went down because it doesn't know how to get there. So now you do a network 10.
Okay, I don't want to sound so basic here, Peter, but in talking about a wildcard, that
0.0.3.
That's like backward from the normal subnet. So are we talking about the wildcard like jokers or wilds? So you've literally asterisked it so that it's able to actually recognize obviously other additional routers that may not be in the same suggested. How do you put that? Okay, I kind of get the concept. So.
Did it wrong. But yes, that is exactly right. It's like a subnet mask, but it's opposite. So instead of 255.255.255.252, it's 0.0.0.3. And like I said, it requires a bit of bitwise addition that is a little more heavy. We haven't really gone into that much, so that's why I just pulled out the calculator and just show you how it's done. And then because this is a /30, I couldn't use the 0. I have to use a 4 because that's the network ID for these 4 addresses that we're using as a point-to-point. Does that make sense?
Show them that calculator link again. To get the wild
Tunnelsup.com is the website, and then subnet-calculator is the folder it's in. If you just go to Tunnels Up, they have a whole bunch of other things you can do on here, but you click Tools and then Subnet Calculator IP version 4, IP version 6. And then you type in the address that you want to use, so 10.1.1.5, and then the CIDR notation it takes. You click Calculate, and there all of the different IP address, parameters, and everything that you'd ever want to know about IP addressing and subnetting. That makes sense? Any questions?
Only another real basic one, if you'll permit me, because I don't want to be going backward here, but in indicating how we set up and look at the command line interface for the routers, I'm struck by seeing all the solid lines between our PCs and the switch, then up to the router, and then the two routers are connected with a dashed line, which maybe I'm a little older, not a date here, but doesn't the dashed line, that to me represented the old wireless condition, but in this case, does that, maybe you could recap in terms of
Okay.
this version of Packet Tracer, how the connections are to be.
All right. So if you remember, when we had this discussion, Mark wasn't here that day, but we had the discussion of cabling, of straight through and crossover cabling. This is where this comes in. It's on older equipment.
Okay.
So the newer equipment will have auto sensing, but if you go from a router to a switch or a switch to a computer, you just use a straight through cable. If you go from router to router or switch to switch, use a crossover cable.
Okay, yeah, I absolutely now I understand. I think it's like that basic question about where to put the monitor on the router.
No,
I was looking
that's
for a cloud connection, so.
No, that's an excellent question, actually, because yeah, on this older equipment, you would not bring this up if it was just a straight through cable. So if we grabbed a cable here and went, no, I got to delete the other one. If we deleted this and just went through straight through, it wouldn't work. It's got to be a crossover. And then with Mark, when we set this up, he used this lightning bolt connector, which was an auto sensing thing. So it automatically put in this dotted line.
That really blew out some cobwebs, so I appreciate that.
Yeah, well, it blew out some cobwebs for me too. I'm like, why is that? Oh, it's a crossover. Oh, that's why.
So another point with this line here, let's say these two, network A, network B, were not close to each other, like maybe not in the same building, but different cities, you would need different technologies than just Ethernet, copper, because you can't go that far. They have distance limitations with the specifications. So what Peter would have to do is go into these routers, and he would have to add in a module for a wide area network. So he would drop a module in there, and one of these, if you click on it, they'll have some, yeah, right there. Oh yeah, you gotta turn the power off. But you drop in this module, and if he zooms up, if he zooms in a little bit, he can see this. Zoom in, click that, yeah, right there. You see this module. These are actual modules, and they look like this. They're, you know, maybe 5-6 inches wide or so, and they're little modules with the 1 or 2 or 4 ports. And you buy these, you plug them into the back of the router, and it becomes then a WAN technology for long distance. They have different speeds. It's not Ethernet. It's not your typical, you know, local area network type connection with fiber optic or copper. And so by doing that and adding it to these two routers, then he could connect them long distance with some type of leased line that he would get from AT&T or Verizon or something like that. And then when he drops these two in, what'll happen then is if he uses that lightning bolt connector, or the red connectors, it's going to connect it with a serial connection. And so just drop your line right there. Yeah, serial 1 to serial 1. Yeah, and then you can kill the other one. But now it has a long distance WAN or wide area network type protocol, can be used for long distances, can be used over some type of circuit that you acquire and your company pays for, like a leased line. And then that can go hundreds of miles. And so if this was, one was in New York and one was in Houston and one was in Portland or whatever, this is the type of technology that you would use for that. And then when he goes in and goes to this config, he's going to see in the config here, if you go into that, Peter, you'll see the config and you'll see the serial interfaces that that are there. and then can actually configure those. Same deal. It's a subnet. You got to configure an IP address and subnet mask and so forth. But it's now serial 0/1/0 or serial 0/1/1. And the 011, those slashes, that just means 0 is that slot 0 you plugged it into. And then there's is it the 0 port? There's like I think four connectors. So it's 0 connector and 0 port, or 1 port. Anyway, that's what the slash is, just to try and so you can know which port on that multi-port module you are connecting a cable to. The nice
While
thing
he's
about
talking, I'm reconfiguring this to use the serial.
you can do it
port
all.
here.
You can do it all from command line like he's doing, but a lot of this can also just be from that drop down config, that second one in, and you just click on the interface and then put in the IP address and the subnet mask and type it into a GUI or GUI. That way you've got the ability to just set it up and configure it either way, get practice either way with the config, with using a GUI configurator or actually the actual commands. And ultimately, like Peter said, you would remote into one of these, either connecting with a serial cable, console cable, or if you set up a auxiliary port or a console port, then you can just type in the IP address, and or even, well, see, these routers are connected networks, so you can SSH to that using PuTTY or some other secure shell, and make configurations remotely. So it's 2:16. We got just a couple more minutes, and I want to direct your attention over to the Moodle page. And on Moodle, we have my home, and Peter can pull it up if he wants. We have this lab. So this is, I know we've gone through a lot of this lab just here directly with you. So if you've been following along, taking notes, then you've got a lot of this lab done. So this first lab here, though, is the, you'll see that if we go down a little ways, it says, get your quiz 1 here.
Yep, we're up now. So Moodle page. Oops, wrong thing.
Okay, I threw your quiz down here into February 22nd through 28th that week. You'll see quiz 1 down there. All right. And you'll see this CSC345 Packet Tracer Lab Word doc. And I've got some Cisco iOS commands above it, a Word doc for commands, right? And let's see, am I just, yeah, okay. And that quiz 1, and then you see where it says upload your Packet Tracer Lab file here. So Peter, if you go into Packet Tracer and go to File.
Packet Tracer.
Yeah, and then go to File drop down, and then go to Recent Files.
Recent files. Okay.
Yeah.
I don't
right
have any
there,
recent files.
You should. Well, okay. You've right here up above at the very top, it just says Cisco Packet Tracer, /users. // users / ptruax app data local Microsoft Windows netcache. Not sure why it's saving it there, but it normally saves it in a saved document. If you go to, wherever you save it, it doesn't matter. But that file,
Okay.
now when you
so
go to recent files, I think it will show you that there.
we did that, and then so if I want to do the other one, it's fine.
So it'll open that up. And this file then is what we want you to just get and upload to Moodle.
Right.
And I can even just share if you want.
Yeah, go ahead.
Okay. So,
But yeah, these packet tracer files is what we're looking for.
two. All right. So packet tracer. Let's see. Are you seeing my screen? Is my screen sharing with?
Nope, I can't see it.
Okay, I got to go. Okay. There. Now I see it.
All right.
Okay.
Yeah, there's your big network.
Ultimately, have a Portland, Houston, and New York router. Use a serial connection. Create these wireless elements of laptops and printer with your DHCP and DNS server and web server. And what I was saying was just recent files right there. It typically saves this PKT file under users, your name, Cisco Packet Tracer 7.3.1 / saves, and then the file name, in this case, CSC345 lab. Maybe put your name on that file when you save it and upload it. So, but it'll be assigned to your name anyway.
And Mark, I don't want to be whiny about this, but if we get the mapping done, we get this example done, do we need to have all green arrows on all those? Do they all have to be fully functional, or what's the minimal point of that you're going to want to see us do this? I know that you want it functional.
I want these all green here.
Okay, that's what I thought.
Now, if you have a question, just reach out to me and Peter, and we'll just walk you through it real quick.
Yeah.
So I did this with logical, and then I did physical. And if I zoom out, okay, this is what I did. I put there. I did. I need to change these city names here, but Portland, Houston, New York, and in each of these there's your city, there's your Portland office. Here's my office. Here's my cubicles or offices, and there's my comms closet with my equipment in there. Okay. So, so this is just a fun lab. It should be fun to do. Shouldn't take too long. I've got all the instructions are right here in this packet tracer lab. I lay it all out for you, and hopefully you can figure it out from what we've talked about today. And those things you can't, just give us a quick call or a text or email or something, and we can help shoot you the commands so you can get it running. But it lays out all the stuff we want you to do. So we want it to ultimately, this packet tracer lab, we want it to ultimately look like this. And when I go to logical, it looks like this. Okay. Any questions?
No, sir. Thank you.
Okay, and if we go back real quick to Moodle, and we can change this if it's too difficult, but upload packet tracer lab files here. What does it say? By Tuesday, March 2nd? Is that too soon?
Yep. Well,
That's
4
this
days, 9
Tuesday.
hours from now.
That's this Tuesday.
Yep.
Okay. So let's edit this and let's make this then due date by the end of next week there. March, we're in March now. So March, Friday, March 5th.
Yeah.
Friday, March 5th. Okay. Midnight. Oops. Okay. All right. So that gives you something to shoot for. Got a little over a week here to go through it, build it out, send us some feedback. Specific commands, give us a call. So hopefully this is a fun project. And I have this diagram. I just snapped this screenshot and threw it in there. So I've gotten laid out all the equipment. You got to just drag and drop. Use the lightning bolt to auto connect all these together. You know, some of these with wireless, you're going to have to, you know, stop it, turn it off, drop in the wireless module, turn it back on so you can connect it wirelessly for those 2 laptops and printer. And then you got to have those 2 servers and then turn on DNS, DHCP, and web services like we did last Tuesday. Okay. And I will upload a video for you. So there's another professor who's done this kind of similar, and I'll upload his. So there's a few changes we wanted to do just to give you some like what Peter just did with EIGRP, this enhanced internet gateway routing protocol, this dynamic routing protocol. He doesn't do that. He just uses RIP because that's easy to configure on the config dropdown. But you got to go to the command line to do EIGRP. So some command line, not too much, but just give you a little practice here.
All right, I'm
Okay.
gonna stop recording here.